So yeah, today I'll talk about this tracing Kafka. So first, I want to ask, are there any SREs in the house? Site reliability engineers? Cool. Hi. I share your. Who am I? So I work at a company called Agolo. My name is Mahmoud Saada, but people call me Moody because it's easier. But at Agolo, we do what's it called? We summarize the news basically. So we use NLP technology. We have an ETL pipeline basically that we use to scan, organize, and summarize news for enterprise companies. And you can find me on Twitter here. And a fun fact about me is my name is really long. It's Mahmoud Midhat Yusuf Abdurrahman Saada, which is basically how I'm from Egypt, and that's how we basically trace our ancestry. So you know my dad's name, my grandfather, his dad, and so on. It's like, yeah, it's like a trace for our family. So I work on a bunch of open source stuff. I like to work with the Grafana, Prometheus community, Elastic, Terraform, Docker, Kubernetes, all the SRE exciting stuff. It's an exciting field right now. But I've been interested in observability for a while. I worked on this project called Container Hive, which is basically this GIF you see on the right, which is I wanted to see the network requests going from curl containers to an Nginx server and kind of visualize it and see what it would look like if you could sort of real-time trace the requests. It wasn't very useful, but it looked cool. So for the agenda today, we'll talk about tracing, Kafka, and then a demo and some gotchas. Hopefully the demo will take most of the time. As you can tell, this is a trace also. So observability. So the whole point of tracing is we all care about observability. We want to understand our systems. And we have logging and metrics, and Juan went in depth about why tracing is important. So I'm not going to talk a lot about it, but basically the idea is that you want to be request scoped. You want to look, like tracing is kind of the nice middle ground between metrics and logging. It's a way for you to visualize the journey of a request throughout all the services. So this is what it looks like. You guys already have seen this demo, so I'm not going to go in depth. I'm just going to cover stuff that maybe Juan didn't cover, which is you actually have logs in your trace. So in your spans. So as you can see, if I can move the mouse here, so you can see there's like a log right here, as well as some tags and some metadata about the request. And you can think like things like say a MySQL query. If there's a span for a MySQL query, you can actually log like the query itself and kind of debug it from there. So if you forgot to create an index or something like that, it's a good place to look also for that. And the nice thing about Jager which is the open source solution from Uber that is built on top of open tracing, is that you can get these visuals. If you're on like a Spark job, you can get a nice diagram that is automatically generated for you with a good idea of what services are most popular, basically. And how many people here use Kafka, run Kafka, or are involved with Kafka at all? How many people enjoy debugging Kafka pipelines of those hands that were up? Or like where a request stopped halfway or at the end? Yeah, that's why I made this talk, so awesome. So yeah, Kafka, for those who don't know, Kafka is basically like a real-time message bus, basically, an event system. And at Agolo, as I said, we run an ETL pipeline. We do a lot of NLP to summarize the news for our clients. So sometimes things go wrong. Sometimes the message stops halfway through the ETL pipeline. We don't know what happened, or something's taking longer than usual. So Kafka is one of our main backbone technologies for that. And in terms of, so why would you trace Kafka? So It's the central proxy for all your transactions, right? Uh, all your applications, your stream processors, your databases can all kind of connect to the central hub, this near like almost like a network of all the data that's going through your system. So tracing that makes a lot of sense, right? Well, if you can trace that central area, you can get a lot of information. And also it facilitates end-to-end debugging. You can follow along the journey of the request. It helps you with if you're running ETL. It's very helpful for that. And another thing that's common in Kafka is that you, especially in bigger companies, if you have people consuming your event bus or your topic, as we call it, you don't know, sometimes you don't know who's consuming you, right? You don't know who your consumers are, who your customers are. And tracing can be a good way to kind of get a quick idea, okay, who's consuming our app like 3 years later as the company grows, as more teams consume your topic. So for the demo that I have for you is basically we have users. Our users want to, it's basically going to be a Slack, kind of like a Slack chat application. Users communicate with the web app and a chat API. The chat API talks to Kafka, and then we have a storage service that basically consumes from Kafka the events that happen. So if a user sends a message, it receives that event and then stores it in Redis store. And then our web app basically pulls the API every few seconds to get the latest messages. And Redis is our main store for that. And then we, in addition to that, one of my favorite features in Slack is that you can put a plugin called Jiffy, and it lets you kind of generate GIFs. So I basically have the same idea, a GIF service that consumes like the messages, and then every time it sees a message that starts with /Jiffy, it basically takes the next word and then queries the Jiffy API and it attaches like a GIF to the message, basically. So actually, if anyone has a laptop or that would like to join the chat conversation, you're welcome to. Yeah. So let's do it. Yeah, so what we have here is I have a Docker Compose that basically describes our backing services. Obviously, you can run this on Kubernetes, but locally, it's easier sometimes to use Docker Compose still. So we have Kafka, Zookeeper, Redis, all the Jager stack, which is basically everything below, and the Spark job that generates the directed graph that we talked about. So first thing I'm going to do is I'm going to go here and I'm going to spin up our Compose here. In the meantime, while I spin up all the services up, let me make sure we have a URL we can use. So whoever wants to join the chat. So this is our chat application. You can join through this URL, which is 66C4D4A6 .ngrok.io. If you guys don't know ngrok, it's basically a tunnel system that allows me to expose something to the internet from my laptop. Awesome. So basically what we have here is, it's still not working. It's this is the default messages, but you can basically type a message. It's not working right now, but we need to spin up our services. And you can edit your name up here. So I can change it to Moody, for example. Yeah, okay. So first thing I'm gonna do is I'm gonna, so we have the web app running here. I'm gonna spin up the chat API. I forgot to say these are all Java applications. Yeah, except for the web app, which is running like React and. Uh-oh, demos. Oh yeah, no, that's fine. So we have our chat API. We have our, down here we have the storage service, the Jiffy service. And as soon as they come up, this was a lot faster before, but for some reason it's taking some time. So yeah, now that we spun up all the backing services, everything is up. So the Java application should be able to hook into Kafka, hook into Redis, and start polling, hopefully. Uh-oh. Yeah, this was part of the demo. The idea is to throw you guys off and start showing you this is what real life tracing looks like. Okay, so what's going on? Oh, okay. It's because we still don't have messages. So the service didn't actually crash. It's just early. So let's go here. Okay, there we go. So if you're already on the app, you can start sending messages. But basically, I can say, hey, hello. And if you noticed, after I tapped hey, hello, the message kind of disappeared. So it seems like there's a bug or something that we need to fix. So let's go into our Jager UI. Let me just refresh here. It should have appeared by now. Nope. Let me go back here. Okay, so if I say find traces, great. So we see some traces here. All our services are listed up here. Chat API, Jiffy service, and storage service. And we can look in the dependency graph and kind of get an idea of what we have here. So kind of who talks to who and how popular is a service, basically. So that comes from the Spark job that I talked about. And then what I wanted to show you guys is if we kind of filter by the storage service. I was going to play some New Orleans jazz, but there's no time. What's going on, Jaeger? Let's try maybe the Jiffy service. My computer is running really hot, actually. Okay, there we go. So we have one trace here that took, gosh, 80,000 seconds to process. So, and it seems like, looking here, oh no. Okay, actually, you know what I'm gonna do? I'm gonna start these services up again because it's, this time I reset everything. So flushed all the Redis data, the Kafka data as well, Cassandra. So we should be on a blank slate and hopefully it should work. But yeah, basically to answer your question, so basically the way it works is the headers, Kafka introduced a new feature, which is you're allowed to add headers to messages as of, I believe is as of 0.11. So if you're running 0.11, you have access to the headers, which means you can do context propagation of your trace. And for Kafka streams, actually, there is one thing I can talk about while everything spins up, actually. So, yeah. So basically, when your trace is created, the way this trace looks like. So the first service here, that's where your trace ID gets generated. And that trace ID, in order for this beautiful UI to show up, that trace ID needs to be, every service needs to be aware of it across the whole journey of the request, right? So in order to pass that trace ID, we use the headers in this case, and we call that the trace, and everything else that's around the trace ID it's called context. There's things like baggage, so you can kind of pass baggage down across services, which is just metadata that is specific to your service. So I'm using a client here. Where is it? So let's look at the chat API. So for the chat API, if we look here, yeah, so these are the libraries that I'm using. So obviously the Kafka client, the Jaeger client, and then we have 3 open tracing clients. These are open source, so you can look them up. And I have them as in the references as well. But basically, these are wrappers around the official Kafka client, the official Redis client, and in this case, the Spring Boot application. For Spring Boot, I had to do, so Spring Boot in our case is where the trace ID gets created. And the library that I'm using offers us this bean that allows us to, in our main class, to create our own custom tracer. So here, as you can see, I'm using a class called configuration from the Jager tracing package itself. And that allows me to give it a name, to give my service a name. So in this case, I say my service is called Chat API. I want to sample every single request because we're testing right now. And I want to report it to the local host Jager agent, right? And that automatically generates a trace on every HTTP request and allows me to start, and also sets the global tracer. The global tracer is just a convention to make it easy for you to access the current instance of the tracer. And if we look at the chat controller, you can see I have a GET request and a POST request. The GET request just gets all the messages from Redis, and the POST request is where we actually send the message to Kafka. So let's look into that. So right here, so we call create in our Spring controller, and in there the first thing we do is we initialize the message itself. We set like timestamps, and we also do like validation and things like that. And then we send the Kafka message here. The Kafka message basically instantiates a producer, Kafka producer. This is standard Kafka code, so anyone who uses Kafka should be familiar with this. And then one thing we say here is we set the client ID as Chat API, so my consumer ID is basically Chat API. And then the different part here would be this line right here. So that, we basically create a tracing Kafka producer and pass to it the regular producer and an instance of our tracer instance, our Jager tracer instance. And that returns to us the tracing producer, which has the same API as the regular producer. So I can call producer.send, producer.close, and behind the scenes, because I told it where to find the tracer instance, it knows how to pull out the context, inject it into the headers, and pass that along. So any other client that's consuming those Kafka messages with the same library, they also will automatically extract any headers that have the span context in it, and put it in whatever tracer instance. And we'll look into that next. So if I go here, so the next service along the line was the storage service. So the storage service similarly, right here, so we have a while true, and we keep polling Kafka basically for messages here. This consumer is also instrumented with tracing, so the same exact way as the producer we just saw. And one more thing here is we also have the Redis client, and the Redis client is also instrumented. The same exact API. You pass in your Redis client connection, and you pass the global tracer instance, and that returns to you a Redis connection that's basically instrumented with tracing inside. And now you can make normal Redis requests. So if we look down here, we have a redis.set, redis.zadd, or sorted list add. And behind the scenes, the Redis client does the same thing. It takes whatever the current context is, or sorry, it sends a trace to the Jager agent and tells it, I just made a set request, here's the key that I used, and so on. The one thing I wanted to show here is the how I extract the context from the headers. So here you can see there's a helpful, like a util API here from the library that I'm using. It allows me to call extract span context, and I pass to it the headers from the record that I just received. So for every record, I take the headers out, and basically that injects it into the global tracer. And now we are able to do regular tracer open tracing API. So if you're used open tracing at all, this is how you kind of create a span. You say, you get an instance of your tracer, build span, and you give it a name. So in this case, we're doing the store function or action. And we say, I want it to be the child of the parent span that we got from our Kafka consumer, right? We start it, and everything in this block basically defines the duration of that span, right? So if this block takes a long time, that span will be large. That's basically the idea. I wish that the demo went smoother. Let's see if it's up at all. Oh, I think it might be working actually. Hey. Yeah, okay. So there's the delay. So you saw the message kind of disappeared and showed up again. So the idea was I wanted to show that we can kind of try to debug that issue. Why did the message disappear and then show up again? So if we look here, say find traces, nice. So we have this right here, and we can see that, oh, it seems like our SLA is broken. One specific service took like 5 seconds to store the request. So we know it's a storage service. We know it's right after we received the Kafka message. And one thing I wanted to show here is the instrumentation automatically injects the partition, the offset, so you know exactly which partition your message came from. You know the topic, so the topic is called message. All of that was done behind the scenes without me doing anything, just using the wrapper. The same thing for Redis here. We see the key of the message. We see that it's type Redis, yeah, and so on. I just want to show that a lot of these traces are instrumented for you using these open source clients. So yeah, so let's see, why is the store service taking this long? If anybody has noticed already, there's a little try here where I do a thread sleep for 5 seconds. So the majority of the duration was asleep, but in real life, this could be maybe you forgot an index or regular performance issues every day. So I'm gonna remove the intentional thread.sleep and restart the storage service. Yeah, good question. So the question was, am I using the latest version of Kafka? Because you faced a similar issue. So actually, I'm using Kafka 2.0, which just came out like 10 days ago or something, but for the demo. But you should be able to do this with 0.11 and onwards. Since that's where they expose the headers. Otherwise, you'd have to inject the span inside your message, which is not good practice, right? You need to have header access, which is from 0.11 and on. One thing I want to mention is that if you're using Kafka streams, that actually the headers are not exposed in the clients until 2.0, which just came out. So unfortunately, you don't have access to your record headers if you use Kafka streams today. What else? So yeah, what I wanted to show is now that we restarted the service, that hopefully the bug should be gone. So if I say hi, nothing's disappearing. Awesome. And then let's try the GIF service. So I can say hello demo. Cool. Yeah. Well, I was hoping that people would participate, but I guess it's hard to join. But yeah, that's basically the idea of the demo. So back to the slides. Before I go to the slides, actually, I want to show one more thing. So right here, yeah, I want to show that the trace after we made the fix. So now we see the storage service just takes a few milliseconds instead of the 5 seconds. Another thing we see is that there's a big gap here. So this is basically the time it took between the after the message was sent to Kafka and then it was received all the way right here. right? So there's that time window where nothing happens basically, and it's so if you see this is a kind of expected because it's not a real-time pipeline. There's a little bit of a delay. In this case, we're talking about 500 milliseconds or something, probably because my computer is slow, because it's on this chair. Yeah. So going back to the slides to wrap it up. So I wanted to go over some gotchas. I already spoke about some of them from the questions, but basically sampling strategy was really confusing at the beginning. There was very little documentation. After I filed this issue the next day, yours truly, Yuri, responded with a full page of documentation with details on all the different sampling strategies. So thanks, Yuri. That was really helpful. The record header support in Kafka Streams. At Agolo, we use Kafka Streams. It's essential to our pipeline if you do any stream processing. But now, finally, there's if you upgrade your clients, you can access the headers. If you upgrade to 2.0, yeah. Don't forget to tag your environment. We used to throw all our spans and traces into one Jaeger collector, and it gets confusing if you don't, label your agents with like environment staging or environment production or which location you're running on. Don't lose context. So in this case, you saw we used like HTTP headers. We used Kafka headers to do context propagation. Use those metadata fields to your advantage, basically, if you're writing your own custom tracing client. And then archive your traces. As SREs, we sometimes forget, traces can take a lot of your storage. Make sure you have like a cron job or something that goes back and cleans up all the old traces or puts them somewhere where for archiving. And sometimes you might need more information. Remember I told you there's that big gap in the middle where nothing was going on? You could use, monitor your Kafka clients. This is something I just learned about recently, is that you not only can you monitor your JMX metrics from the brokers, but you can also do the same thing on your clients. If you're running Java, the clients already expose all the metrics for you. You just need to scrape them. I have a pull request on Prometheus to make this available for everyone. But you can basically get like detailed network latency information inside the client. Something that would be awesome is if the Kafka client itself was instrumented, so that we can get that gap would basically be filled with what actually happens on the client side. So that's about it. The resources, the source code for the demo, you can find it here. So yeah, thank you. Any questions?